So today we are going to solve next three problem of difficulty level 1700 in the same row. Okay, so we are solving these three problem. So this is a very easy problem, easy version of the problem. Okay, the only difference is here k is equal to k. You can have only both the problem. Okay, this is an inductive problem. Every decimal number has a base k equivalent. The individual bit of a base k are called k bits. Let's define k bits. XOR of 2 bits will be a b mod k. The k bit XOR of base are equal to a new number formed by taking k bit XOR of their corresponding k bits. The k bit wise XOR of the decimal number a and b is denoted by a of b. Okay, and is equivalent to the decimal representation of k bit wise XOR of f a and b. All further number used in the statement. Okay, but in our case in this problem we are using the bitwise XOR k is equal to 2. You have hacked the criminal database of RPD, also known as the rapid sheet. But in order to access, you need to require password. You don't know it, but you are quite sure that it is lie between 0 to n minus 1 inclusively, so you decided to guess it. Luckily, you can try at most n times without being blocked by the system. Okay, but the system is there too, so each time you make an incorrect, okay, especially before the guess and k is equal to, it will give 0 if it is not correct and 1 when it is you guess the correct. Okay, so uh let's say we have a value x, that is our password. Okay, but when we guess something y, so the password will change x or y. So we can and we also know that the password will become 0 and minus 1, and we also gonna guess from 0 to n minus 1. Okay, so first of all I need a password. All right. And we can ask n queries. Okay, so n queries, so I want to I can ask n queries, and I know that answer will be 0 to n minus 1. That means n queries, so I need to check for all values 0 to n minus 1. Okay, so first of all I need to check 0, then 1, then 2, then 3, up to n minus 1. But here's a catch, that password will be adaptive and it will be changing every time, so we need to take care of that of this password. Okay, so you can see that let's say we guess 1. First of all we guess 1, and password let's say something x, and it is not 1, so password will be changed x1. When I guess 2, then it will be changed 2. Okay, so when I need to check for 3, can I say that I will be checking for y is equal to 3, XOR 1 XOR 2. Okay, then if y is equal to, let's say y is equal to 3, I'm guessing for 3, then I'm also making y equal to all the XOR I already applied to x. Okay, then if x is equal to 3, then our answer will be 1, then it will gonna return 1, then it will be gonna match. So what I'm asking to say that, like, previously some XOR action will be applied. Okay, now if I'm checking y from 1 to 0 to n minus 1, and I'm also applying all the XOR to this same. Okay, so if x is equal to y, we will gonna get return 1, so we don't have to worry about it. So let's say for 0 1 2 3 4 up to n, I'm just checking for all of these. Let's say x is equal to 4. First of all, at 0 I didn't applied anything, so I need to check y is equal to 0, so password will become x is equal to x XOR 0, so it will become 4 only. Then when I'm checking for y is equal to 1, so password will become 4. So I will not check, I will not in the query I will not put y is equal to 1, I will put y zor y minus 1, that is 0. Up to yet we are just putting y zor 0, that is y. Okay, and when and I see that like it will become 1 and it is not equal to 4, that is x. So x will become, so x will be equal to x zor y zor 1, that is 0. Okay, so if I want to initial, so this will be x dash. Okay, so x is equal to x 0 zor, because I applied this one, that is x dash uh, in the first query. So in this second query it will be changed to y zor 0. So you can see that when it 0 become 2 times, so it will be gonna cancel out. Like I know that a zor a is equal to 0. Okay, so it will be simply become x zor y, that is equal to x zor 1. Okay, so when I am asking for 2, y is equal to 2, so I know that x is changed by only one element, that is 1. Okay, so I need to change y is equal to y dash, I need to ask for y dash, and y dash is equal to zor 1. Okay, it will become 3, and let's say 3 is not equal to x, that is equal to something here. Okay, now after this operation, the x will become x, new x will become that is x zor 1 y dash, and y dash it will gonna zor it out. So you can see that y is also cancelled because it appeared 2 times, so x will become x zor 2, that is y is equal to 2 here. So you can see that at every time we need to pass y, that is y zor y minus 1. Why it is so? Because after all of these will be gonna cancel out, or I will say all will be gonna appear 2 times, so that will be x zor x. Oh, then each of the item below y minus 1 will be appearing 2 times, and zor of two equal elements is equal to 0, so we don't have to worry about it. So we need to only check about y into y zor minus 1, that's it. So it's a kind of a simple code. If you understand this so you can write your code. And so now I'm just jumping on the code. If you don't understand it properly, so follow me on code. So first of all I need n comma k. Okay. Then I need to check for I is equal to 0 to I minus I n minus 1. What I need to carry out, I need to see out, that is if I is equal to 0, then I need simply carry out 0. Okay. Now else I need to put I zor I minus 1. Here we go. And in result and scene result, if result is equal to 1, we're gonna break it out. That's it. So this is a kind of very simple code. So let me check for this one. Oh man, I this is an interactive, so we can't check, so we need to submit it. Oh, oh. Yeah, I think, yeah, rejected. So let's move to the second problem. So this is the second problem. You are given two integer a and b. In one turn you can do one of the following operation. Take a c, that is a should be divisible by c, and replace a and divide the a with c. Same case you can do the same scenario with b also. So your goal is to make a and b using exactly k turns. Okay, okay. So what we are given? We are given two integer a and b. A and b. So first of all, I need to make them equal. Okay. So how I need to make them equal? So first of all, for let's say I'm just thinking of how many maximum I can apply. maximum like operation I can apply. So maximum operation will be when a is equal to b and both is equal to 1. Okay, and a is equal to 1 and b is equal to 1. So at this case we are going to apply the maximum of operation. And what will the value of maximum apply? I will gonna say that I will gonna represent a in a form of some prime numbers. Let's say 2 is power 3, 4, 3 is power 4, then 5 power 2. So I can say that I can maximum divide it by 3 plus 4 plus 2 is equal to 469. Okay, because let's say if it is 8, that is 2 to power 3, then I can divide this one by 2 3 times. So if when I first divide 8 by 2, it will become 4, then further I divide 4 by 2, it will become 2, and then I divide it, it will become 1. Okay, so I'm just trying to find out what is the maximum operation I can apply. So you can see that it will be equal to sum of the power of different uh, you can say different prime numbers. Okay, okay, a and b, that's it. So we need to check if it is, if k is, let's say maximum, it is count 1. Similarly for I counted 2, that is count 2, I need to check if count 1 plus count 2, that is the total count, the maximum number of apply can I apply. If it is less than equal to k, then I'm 100% sure that I'm just able to do that. Okay, okay, how it is possible? Let's say if it is for a, I can say like max in, I can make a to 1 in maximum 9 operation. So if it is given, like you can make it into 3 operation or 2 operation. So in 3 operation I can easily make. So first of all I divide by 2's power 3, then in second operation 2's power 3 power 4, then 5 power 2. And if someone say you can make into 2 operation, so let's say it is 2's power 3, 3's power 4, and 5 power 2. And even k is equal to 2, can I make it equal to 1 in 2 operation? So I will say first of all in one operation I will divide a by 2's power 3 and 3's power 4. So it will become, a will become 5 power 2. In second operation I will gonna divide it by 5 power 2. It will become 1. Okay. So by any operation that is less than the maximum one, I can make it equal. So but there is test cases like, but let's say there are some corner cases, something like that. This is valid, okay, but there are corner cases we have to check about the maximum. Okay, we have to check about the minimum ranges also. So let's say if k is equal to 0, if k is equal to 0, okay, first of all I need to check how, what is the minimum number of operation I need. So what I'm saying is I need to, I make them equal. Okay, I'm making them equal such that both will become equal to 1. To make them equal I need at least k is equal to 2, so that I can divide a by a and b by b. Okay, so if k is equal to 2, if k is equal to between 2 to count, this is the maximum value, so I can say it is easily possible. Now I have to check for the corner cases, that corner cases, that is k is equal to 0 and k is equal to 1. So if k is equal to 0 I can't divide anything, so it will be possible if a is equal to b. So if they are already equal, so I can say they are equal. If k is equal to 1, I can say I can only divide it by 1. So I need to like, let's say it is 4, 2 and 8. If they are both are already divisible, or both have like if the minimum value, I can say, I will gonna say the max of both two, and the minimum, like the minimum is the divisor of maximum. So in one by dividing by one time I can make it maximum by equal to 1, something like example like 15 and 3. So 3 is a divide, 15 have a divisor 3, or 3 is divisible by 15. So I can say that by dividing 5 in one operation I can make both them equal. So just I need to find these two, and this is the test case. So let's check about the time complexity. So if we gonna see about time complexity, so test case a and b. So in what is the time we can find about the by this So I can say that, but I can easily find out the prime in, you can say, power of a, under root power of a. So and in I into I. Okay. So in under square root of a, that is will be 10 to the power 9 square root. I can find out a, and their total test cases are 10 to the power 4. Okay, so it will be around 10 to the power 4 into 10 to the power 9 will be 5 into 10 to the power 4 around. So it will gonna, it is 10 to the power 8. So I think it will gonna give me TLE. Okay, because in 1 second or 2 second we are just make up to max 10 to the power 8 if the our operations are not that much, our small, like addition and subtraction. So these will, or this is gonna take time. Okay, and approximately we can make about 10 to the power 7 operations generally. So it will gonna give me TLE. So we need to find out uh, another way to find the primes. Okay, so let me write the, so I will gonna optimize in the code hole, in the code. So I will gonna tell you what is the optimization I'm doing. Okay, first of all I'm just writing the algorithm. Let's see it will gonna give me TLE or not. So first of all this will be int a, b and k, b and k. So I need to count one. Count one is equal to find all, find all, find divisors, divisor of a, and int count 2 I will gonna say find divisor of b, and I need to check about the corner cases. So let's say I'm just making a bool value is equal to false. Okay. If k is equal to 0, it is only possible when a is equal to b, and if they are not possible, I mean say I'm not gonna make it. So while we're gonna store that if I can able to make it or I will not able to make it. I will say if it is not equal, k is equal to 0 and it not equal, so I will say I'm not gonna make it. If k is equal to 1, and I need to say max of a comma b must be a minimum. If it is not equal to 0, if they are not divisor, I'm not gonna make it. So while I need to make it false. Okay, let's say if I'm gonna make it else if and else. So else I will say if count 1 plus count 2, if k is less than, or when I'm not gonna make it when k is more than this. So I will say I'm gonna not able to make it. I will do false. So in these three cases I'm gonna not able to make it. Okay, otherwise I'm gonna make it. I will gonna make them equal. So if it is value equal to, I say I will make them equal, will be yes, else I will gonna make no. Okay, so I need to implement this function only. Int count 1 int a. So I can easily make into I is equal to 2. This is a standard one to find the total number of, you can say, wait a minute, find out. So this is a standard algorithm, you can say algorithm to find the divisors of an element. Okay, so while a is remainder by I is equal to 0, I will gonna make it a is equal to a divided by I and count plus plus and say return count, and if a is greater than 1, count plus. Okay, so this is a standard algorithm. So we're gonna just need to if it how many divisors of a are. That's it, I think so. So let me check. The fourth one is 2 to 1. Okay. Or 8. So if k is equal to 1, so I need to apply k operations. Okay. And if both are equal, like in this example, if both are equal, so I can't make able to make them equal in one operation, because I have to apply the one operation and the divisor. Okay. Because you can say that okay, I can take the c is equal to 1, but it is already given that c must be greater than 1. Okay. So we can't able to make them equal. Oh, a b. Okay, if equal, I'm just taking the first one. Yeah, here we go. I think so it will gonna give me tle. Let's check it out. mm, uh, Running on 10, 20, 23, 27. Oh, I think it will gonna pass out. Oh yeah. Oh, it is accepted. It will not give TLE. Okay. So use this algorithm to find the divisor, so it will not give to TLE. So reduce the A constantly. So you don't have to check for all i's. Okay. So if you're gonna reduce it, so let's say if A is equal to 8, so you just divide it by contrast 2 to 2. So you don't have to check for all from 1 to 8. Okay. Or by up to square root. But if you change a little bit, it a type of on the edge of TLE. So if you change it a little bit, it will gonna give you TLE. I'm 100% sure it will gonna give you TLE if you change it a little bit also. Okay. So yeah. So this is the third problem. So Alice and Bob are playing a game. They started with the positive integer and are taking alternate turn doing operation on it. Each turn a player can subtract from n one of its divisor that isn't 1 or n. The player who can't be able to make his or his turn loses a life, always move first. Okay. So this is the last problem of the day. We are given three a of what a number n, let's say, and I need to subtract. So I will, let's say I'm gonna represent it as a prime values, multiple of primes. Let's say 2's power 3, 3's power 2, 5 power 8, something like that. So I need to subtract something that n is equal to n minus some prime power something like 2's power 1. I'm gonna subtract it 2's power 2, 2's power 3, whatever I need to subtract it. Okay. So for these type of problems, you need to like you need to find out when it is possible or not possible. So you need to check about odd and even is like for any type of odd or even they are maybe there can be a possibility we can take a hint from. If we just checking if n is odd, what will gonna happen, if n is even, what will gonna happen. Okay. For these type of problems, so let's say if n is even, n is odd. So if n is odd, so n is odd, that means we don't have 2's power. So the prime 2 having power 0, it will be 3's power, 5 power and anything else, but it doesn't have 2's power. So if it is odd, okay, so let's say 2's power 3 and 5 power 8. Hmm. So whatever I'm subtracted, so it will be, I'm going to subtract it odd, because I need to subtract the mm any prime, any divisor. So I'm 100% sure divisor will also be odd. Okay, that will be power of 3 or power of 5, whatever it is, or both. Okay, so the n will become even. So here we got a clue. So when we subtract odd, then it will become even. So we need to check what about even. So if n is equal to even, because let's say if 3 is power 2 and I subtract 3 is power 1, it will become 3 is power 2, that is 9, 9 minus 3 to become 6. So it 6 will become even. Okay, because odd minus odd is always even. Odd minus odd it is always even. Yeah. Okay, so if n is even, so n is even, let's say it having 2 is power something and 3 is power something, 5 power something like that. So first of all, what I'm gonna do, if someone get someone need to if it is come even, okay, so if he subtract 2's power, like all the 2's power, then it again become odd. So in this case, if subtract n minus 2's power 3, okay, or it will gonna subtract 3's power 5, all the power of 5, it will become, okay, let's say if it is odd and I need to take out all the even out of it, 3's power 2, 5 power 2 into, let's say, 2's power 2. If I subtract it, 3's power 2, 5 power 2, it will become 2's power 2 minus 1. Okay, okay, okay. So I can make it odd. So you can see that if it is even, let's say if it is become even, so you can subtract something, let's say 3's power 2 and 5 power 2, so it will become this. I know that 2's power will always be even, and if I subtract all the other power, so it will become, I will just take out all the other power, uh, all the other power that is not 2, so 2's power minus 1, so it will 100% become odd. Okay, let's say it will become 4 minus 1, that is equal to 3, so it will become 3's power 3, 5 power 2, it will again become odd. And we need to check, so there is a thing will, like, from odd I can change even, from even I can change odd. So now I need to find out when it will gonna finish up, at odd position or at even position. That's the point. Okay, so can I finish at odd position? Let's say I have 3's power 2, 3's power 2 and 5 power 1, let's say 3's power 3 and 5 power 1. I need to subtract 5, then it again become odd and even. So at the last it will become, let's say, 5 power 1, it will become odd. Then I can't, if it is 2, uh, so if it is 5 power 1, okay, if it is 5 power 1, at the end it will gonna remain, let's say, 5 power 1 and 3 power 1, and I subtract 3 and then it will become 5. Okay, here we go. So you can see that if it will become 5 power 1, if let's say 3 power 1, 5 power 1, it will be gonna, if I'm gonna subtract 3, it will become 5 power 1 to, let's say, minus 3, it will gonna become 5, 3 are gonna 3 common, 5 minus 1, that is equal to 4 comma 3, that is 2's power 2 3. Then I again subtract 2's power 3, then it will become 3 into 3 power 2, so at the end it will become 3 power 1. Okay, at the end it will become 3 power n. So when it become odd power 1, so it will not gonna, uh, so we not able to make it any changes. Okay, but when it is become 2's power 1, then also we won't able to change. But I can say that if it is something odd and even, if it is odd, that will be 100% 3's power 2 and 5 power 1. I can't. Okay, so I can, so what I'm saying, so let me refresh what I'm just calculated all the things. So if it is odd, I can convert it to even, and if it is even, I can convert it to odd. And if doesn't have, let's say, 2's power only, 2's power, okay, so it is a not a like in 2's power only. If it is something having 2's power in even side, if it is having 2's power and something else, 3's power and 5 power, so best strategy, I'm just making even and odd. At the last, it will be finished up at, the odd one will not gonna be make any changes. Okay, why it is so? Because when it will become odd, okay, I'm gonna make it even, and it will not be like 2's power 1. At the end, it will not be become like 2's power 1. Okay, if you're gonna take some example, you will gonna see that it will not become at 2's power 1. It will always be becomes something 2's into odd something. Because how I am making from odd to even, that is, let's say if I am having 3's power something and 5 power something. So if I'm just subtracting something like 3's power 2 and 5, just taking 3 and 5, so it will become 5 minus 1. So you can see that it always be having some odd power that I need to subtract from here. Okay, so you can see that to make it even, to make it even, to from odd to even, so I need to subtract some power, so it will be taken out from here only, then it will become, this will become, and we have some power here only. Okay, so you can see that while we add the even one, so we always have some divisors. Okay, so we can't able to make it one, we can't able finish up at even position. So if you want to like let's say if it is having only 3 and it is only 4, so I'm 100% sure that, let's say, the minimum value here can 3 minus 1, because the minimum divisor will be 3. So one divisor will be here and one divisor will be here 100%ly. So at least two divisor will be present in the thing when we are just making even, so we can't make finish up at the even position. So we conclude here, if it is odd, or if it is odd and having 2's power something and some odd values, then I'm 100% sure that it will gonna end at odd position, that is will be, first will be odd. So it having something, I'm not saying odd, so it having some even or odd, whatever it is. If it is, let's say, if it is odd, then I need to make it even. Then in the first case, let's say it Alice and Bob, then I need to change it here. Here it will become odd, so allies will gonna lose. If it is odd, then allies will gonna lose. And if it is even, and even in the sense it having 2's power something and some other power also, 3 and 5, it is not a perfect of 2's power only. If it is even, if it is even, then allies, if it is even, then allies will gonna make it odd. And at odd only, the we don't at the last at odd only, we not able to make any changes. So at, if it is even, then allies, okay, sorry, Bo will win, because odd will be comes out at allies, Bo will win. And if it is even, then odd will be come out at Bo, so allies will win. Okay, so we just remaining of one case when all are having 2's power something like 2's power 3. Okay, so I'm just subtracting 2's power something and 2's power something. At the last, it will become 2's power 1. Okay, uh, so how many power is subtracted if it is odd? So I need to subtract, make the changes such that how many changes I can do. So it will be depend how many power I have. Okay, because I know the, if it is having only 2's power something, okay, so it will end up to 2's power 1, that at the end, because at the end, but we don't have to make any changes when it will become 2's power 1. At this time we don't able to make any changes, so it will only depend upon, like, let's say 2's power 3. So if we just need to decrease it up to 2's power 1, so how many operation can be done? If it is let's say 2 is power 3, then in it one case 3 2 is power 2, then 2 is power 1, something like that. So he will not gonna make, if allies, if it is odd, then Bob will win. And if so, and if it is if the power of 2 is even, then Bob will win, then sorry, allies will win. Okay. Okay, so if I summarize all the thing, if n is having only 2's power something x, and if x is even, then allies will gonna win. If x is odd, then only both will gonna win. If x is odd and it is even, and if n is, and if it is not the case, if the second case, if having something 2's power, if n is odd, let's say it is not the case, the second case, this is the one case, this is the second case, and n is even. So if it is odd, then allies will gonna lose, so Bob will win. And then if it is, then allies will win. Here we go. Okay, so let me write code for this only. So what we given is that we are just given an and. And if I need to, let's say, make another variable, and one is equal to n, I need to check if it is having n divided by 2 is equal to 0. So n by 2 divided by 2. So at last, if n2 will become 1, that means I am only having 2's power, a perfect only 2, prime 2 is the only prime that consists of n2, that consists of n. So if count is even, then allies will win. Else, see out, Bob will gonna win. Let's say if it is not the case, then we need to check if n is odd or even. If n is even, odd, then Bob will win. Okay. Else if it is even, then allies will gonna win. Let me see, or we missed any some corner cases. Allies Bob. It is not correct. If okay, so if when Bob will win, if it is if okay, so if n is less than equal to 3, okay, so we can't able to make any operation, so I will say Bob will always gonna win here. Yeah, because if n is equal to less than 3, then it will only 1 and n. Let's say if it is 2, then we can't make any changes, so Bob will win. If n is equal to 3, we can't make any changes, Bob will win. Okay, because 3 are only the prime. 8 is accepted. Okay, thank you.